This is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm Donn Felker.
And I'm Kaushik Gopal.
Welcome to episode number 5. So Kaushik, how you doing?
I am doing great, Don. How are you doing?
I'm doing good. Just been really busy at work, and I know that we talked before the show that you've been quite busy as well. So that's usually a good thing with startups. It means you're hustling and getting stuff done, I guess.
True, yeah. I mean, a lot of stuff happening in work, a lot of stuff happening in the Android world as well. I mean, I recently have noticed that there are a bunch of new Android libraries being released, a couple of really good blog posts out. A lot of Google I/O drama going on with people not getting tickets and people getting tickets.
Mm-hmm.
And I've also seen like quite a few interesting posts on testing recently. So I guess at some point we should revisit our very first episode and then sort of talk about some of our further explorations.
I think that's a great idea. I also saw a post recently yesterday about Dagger 2 and Espresso and a couple other testing tools. So I'm really interested to see how that's going to work out because I use Dagger and Espresso as well. But as you've known, throughout this last couple of weeks, I've spent a lot of time with UI Automator, Espresso, and have just run into just a plethora of problems. So I think it'd be great to revisit that with our new found set of knowledge. Furthermore, I have to agree with the topic that you said that there's just a lot going on right now. I run the Android Dev Digest, as you know, and so I collect basically go out and find all of the links that are out there for Android, and I have a huge list of places I go look for them, and sometimes I'll find 15 links. Lately, I've been finding anywhere from 45 to 60 links that I need to actually trim down, and I have to go open and read and inspect every one of those. There is so much going on that sometimes I'll see a cool library and I'll just kind of tag it in my bookmarking system and say, well, this looks cool. I'll just come back and take a look at this later because there's just not enough time in the day to learn about every single library that's coming out recently.
Oh, yeah, absolutely. Is there a nice mechanism that people can send links to Android Dev Digest? Like, apart from the website, obviously, can people shoot links to you directly on Twitter or something? What's a nice way to reach good links?
That's a good question. Right now, the only way to do it really is to go to Android Dev Digest. I should probably set up a Twitter account to make that a little bit easier. I mainly try to automate as much as I can, so it kind of just drops into a Google Sheet for me, and then I can go take a look at the link. So I try to avoid any manual process at any time. But that's a good idea. I think I might have to set up a Twitter account.
Because clearly you have plenty of time in your hand to be doing all this manual work, right?
Ton of work, ton of time.
Oh boy.
Well, the response from the RX Java series that we had with Dan Liu has just been phenomenal. Again, we'd like to thank you, Dan, if you're listening, for coming on the show and educating us all about RX Java. I know personally I've listened to the episode a few times now, even though it is a little creepy to hear yourself talk in your own ears.
Oh boy.
But it's been great. So I just want to say thanks again, and thanks everybody for listening. We're having a great time, and we hope you continue listening.
Couldn't agree more. And Dan has been extremely nice. Even if people go and see in the show notes, like some of our listeners have been pretty active and asking questions about RX Java specifically. And Dan has been really helpful. He throws in snippets there and answers questions. So thank you so much, Dan. Really appreciate it. All right. So what are we talking about today, Don?
Today we're going to talk about image libraries in Android because it seems to be either you could say it's a hot topic or more of a religious debate. It kind of depends on what side of the fence you sit on.
Right, yeah. So we thought image libraries makes a lot of sense to talk about. One, because there seem to have been some new players in the space. And also in general, it makes a lot of sense because the first step is you have to understand why you need an image library. And most people who start off with Android development, if they use libraries like Picasso or some of the others that are out there, people think image loading is like super easy just because the libraries have done such a fantastic job in abstracting a bunch of these concepts. but many people don't realize like what happens in the background. So we thought to start off, we'll touch with some of these points. Like why do you really need an image library in the first place? Isn't it as simple as just like maybe getting a bitmap and setting the bitmap on your image view? I mean, surely it should be that easy, right?
It seems, and that's the way that it was before. When I first got into Android development, that's what we had. There were no libraries that we're going to talk about today. These libraries didn't exist. And early on at my time at Groupon, I had come in, and Mike Burton, which is a co-author on one of my books, also the mobile director at Groupon, he had written a utility to actually go download the image in the background, extending asynchronous task, and did a whole bunch of stuff. And at that time, it was phenomenal because you just had to set the URL of where you wanted the image to do, where you wanted the image to come from, and the image would download in the background and set it on the bitmap on the image view. The problem is we ran into all kinds of issues though with list views and so forth, which we'll get into shortly.
Oh yeah, there are like a bunch of problems. Like what if you had remote images, and what about memory usage? So we should probably start touching on those topics. So the very first part of the show, we're going to talk about like why you need an image library at all. And after that, we'll follow up with some of the existing options that you have.
Definitely.
One important concept with image loading in general in Android is that the cost that's associated towards bitmaps. Now, typically, bitmaps are actually a pretty costly sort of affair. You want to touch upon why it actually is pretty costly? Like a simple bitmap, like a simple image that you have, could actually land up being pretty costly.
Yeah, so I think it's important to know how Android lays out pixels on the screen, and so we're kind of getting a little bit low level here, but it's good to understand the basics a little bit. And so a single pixel on your screen takes up 4 bytes. So even if your image is small, if you decode a bitmap to like a larger pixel, then your memory is just going to shoot up. So the 4 bytes that are stored are 1 byte for red, 1 byte for blue, 1 byte for green, and 1 byte for alpha. So each pixel is taking up 4 bytes for the RGB and alpha channels. So if you have a full screen image, it'll take up about 1.5 megabytes if your screen is at 480 by 800. And so again, that's just if it's just a plain image sitting on the screen. For a deeper example, let's say your file size is somewhere right around 390 kilobytes, which is, a typical kind of image size you would see nowadays floating around the internet. So when we decode that bitmap, it's maybe 1920 by 1280, so it's fairly large. The same image lands up taken somewhere right around 9 megabytes, So let's break it down a little bit further. So 4 bytes times 1920 by 1280 equals right around 9 megabytes. So the images they may seem small when they're coming down the wire, but actually the memory that they take up, the bitmap allocation, does get a little bit costly.
Yeah, I mean, and it's important to understand like the differentiation here because typically cameras these days, I mean, you have 5 meg camera pictures, so like the pixels are typically around like, of the order of like around 2,500 to 1,900. So just imagine the number of pixels that you have there. And if each and every single pixel is taking about 4 bytes, that's going to hugely shoot up in terms of memory. A typical, and this is from the Google Docs, they actually like talk about this explicitly. A typical 5 MB camera picture like lands up taking around 19 or 20 MB on your device. So that's something you really have to watch out for because if this was the olden days, certain devices have a hard limitation of 16 MB. Like your complete application can only have 16 MB. And if you have 9 MB being taken up by a single image, after you show 2 or 3 images, boom, your app is definitely gonna run into an memory overflow error.
Yeah, the out of memory exception is the
out of memory exception.
Every single time I'm not joking when I say this. When I see an out of memory exception in ADB Logcat, I see that, I literally throw my hands in the air, say a curse word probably, and then walk away from my desk because it's one of those errors that can be so difficult to debug. And we had this happen early on at Groupon where we spent at times almost weeks, it felt like, trying to figure out why our list views were blowing up. And sometimes it would, and sometimes it wouldn't. And so the out-of-memory exception is just probably, in my opinion, one of the worst exceptions to get that you can get when you're working with bitmaps, at least.
Oh yeah, that's no fun. OOM, the minute you see those three words, it's no fun. It's no fun to see that pop up in your crash logs.
Definitely.
Just a quick side note. So typically the default, like when we mentioned that each pixel takes 4 bytes, one byte for each channel, that's the default bitmap configuration, which is ARGB_8888. Yeah,
there you go.
That's 4 A's. I was like, just one more. There are other bitmap configurations as well. Like there's the RGB 565, which takes significantly lesser memory, but we're going to touch upon that as we go into some of the other libraries that use it as a default. But it's just good to know, and we'll add a link to the show notes to the various bitmap configurations. Typically, you want to be using ARGB because it gives you that single channel for your transparency layer. So if you want to have transparent images like PNGs, for example, then that's typically a good format to follow.
Definitely.
Just a good aside note.
Yep, definitely.
All right. So given that we know that these bitmaps take a huge amount of space, there's not too much that you can do about it. I mean, for example, if you did want like 1,000 by 1,000 pixel, like on an image to show and take 1,000 by 1,000 pixels on your screen, there's not really too much that you can do about it. The nature of the bitmap format is that it's pretty big. But one thing that you can do is when you actually build the bitmap, you can actually reuse the bitmap containers. Because typically what happens is as you create this bitmap and you load an image and you swipe away to a next screen and you have another bitmap coming up, what's going to happen is this is going to get garbage collected. The problem is like garbage collection it's a double-edged sword.
Yes.
It can be a good thing because you don't really have to worry about memory because it's taken care of for you. But the problem is because you don't have too much control over the memory that's going in and out, it can lead to some unexpected sort of outcomes. One very typical example is if you have a lot of if you have a lot of garbage collection action going on in the background, it is going to make your UI pretty janky because it's going to pretty much stop everything that's happening. It's going to finish the allocation and then proceed with the leftover action. So that's something that typically you have to watch out for. Knowing these nuances will greatly help you understand what's happening in the background, even with these image libraries. And if you ever have to, like how we have to for the wedding party app, you can drill down into the details and probably optimize your usage depending on your specific use cases.
So this is a kind of an orthogonal question for you, and sorry for diverging a little bit, but I know that, since you guys work with a lot of images, do you, at least in my experience, I know when I've worked with the Android camera, I found just lots of inconsistencies across device manufacturers. Have you noticed the same?
Holy mother of God. Oh boy, you went to a very scary place, Don.
That's what I do.
So if there's one thing that I truly, genuinely hate about the Android ecosystem, it's the camera APIs.
Yes.
And I believe anyone who's had to have had the misfortune of building a custom camera sort of shell to their app would have gone through the same or the similar experience. It is no fun. We could go on a whole show talking about what's wrong with the camera APIs, but I'll quickly touch upon something.
Yeah,
so
for sure.
One
please.
thing is the camera like you said, the inconsistencies with the way it's implemented across different devices. That is a huge pain in the behind because you won't believe the quirks in the implementation by each device manufacturer. That's one big problem. The second thing is there's a new API called Camera 2 APIs, which I believe was after 21, API level 21. The only problem is those APIs work only after that API. Like for anything before the API level 21, you're not going to be able to use the camera APIs. Now, so, I mean, the question is, why did they even introduce the Camera 2 APIs? The problem is, and this is one thing that the Android platform has lacked for a long time in comparison to the iOS platform. The cameras on the camera, the images that are taken, and also basically most cameras on the Android devices pretty much suck. I mean, in comparison to the iPhone. And that's been a constant ding against the platform. Like, people always say, like, I love my Android phone, but if only it could take better pictures with the camera. So the Camera 2 API is a significant step forward in that direction. The quality of the images that you get are really good. At least that's what many of the examples that you see point towards that. The problem is, if you are an Android developer today, you can't simply say, oh, I want great camera images, so I'm going to switch to the Camera 2 APIs, because there are still many inconsistencies about using the API. And more importantly, what do you do to all the users who don't have a Lollipop device, right? I mean, like on our app, we support a minimum API of 14. What do you do for all those people? Just like, oh, sorry, you got to use a different camera, or don't use a camera at all. That doesn't work.
No, it doesn't.
So we could probably do a whole show on this. There are so many things.
I think it's good to talk. No, I think it's really good to kind of talk about this a little bit, even though I think we didn't really plan on it, because this is an area I actually started kind of real experience with bitmaps was actually from the camera API. Back in 1.6 days, I built some custom cameras to kind of overlay some images where they're really corny. It was just kind of learning the platform idea, and it was you would have a picture of perhaps some cartoon character, and you wanted to take a picture with the cartoon character. And all it did was overlay that person, overlay that character on the camera, and then when you take a picture of it, it just basically looked like you were in the photo with that cartoon character. It was super silly, but people really like to do it. Now, back in 1.6, I experienced so many issues down to the point where I would get the bitmap, and then all of a sudden, it would just blow up. I spent nearly 4 weeks debugging out-of-memory issues on just the G1 device, which at that point, there was only one Android device out there. And I spent 4 weeks debugging it, trying to figure out what was going on. And in the end, I had to put bitmap.recycle all over the place, and then I had to actually force some garbage collection all over. And the app was really, really chunky and just had a lot of jank to it. So I think talking about the camera stuff is super useful, because a lot of people are going to be using the camera, and a lot of people want to utilize the camera for various different things. So it's a good thing to talk about.
Oh, yeah. And my advice for anyone who has to start with this is, so commons where...
So you have some advice for some people that want to start with the camera, and I said they should run?
That is, yeah. Oh, actually, that is the best advice. If you can avoid having to build your custom camera, then like fight very hard with your product team to avoid that. I totally got suckered into it. I didn't even realize what I was getting myself into, and I did. And oh boy, was it. So in Wedding Party, we actually released a feature pretty recently, and it's called the photo booth feature, which is very typical for something that you would have in a wedding. It's actually a really nice and fun feature, but the thing is, we have to control the camera. For example, you want to be able to take 4 images subsequently, one after the other. And man, with like some of the issues that you mentioned, they immediately sort of crept up, because just imagine you're taking 4 images in one after the other. And if you have a marginally decent camera, like each of those are going to be like 5 MB camera images being generated. So looking back at what we just mentioned about how much space would be taken just for one of those images, like you can imagine the memory that's taken on your device is like immediately going to shoot up. So there are like a bunch of things that we have to do. So like any sort of optimization we can eke out from taking the camera. For example, step 1 is you have a camera image, you take the camera image and you try to reduce it to the least resolution that you can. And there are some techniques that you can use using inSampleSize, and we'll talk about some of those a little later. But anything you can do to sort of tweak the optimization, reduce the image size, use only the image size that you want, anything that you can do, you'll have to do it right away, because taking 4 images one after the other, like you would imagine it's pretty simple. Oh boy, it's anything but simple.
Yeah.
And pointing to another thing that you mentioned, in one of your early sort of apps, you had to like call bitmap.recycle constantly to be able to make sure that you're releasing the bitmap.
Yeah.
So that's another minor quirk that people should know. And I think Chet Haase has a very nice DevByte on bitmap allocation. So That's definitely, we'll add a link to that on the show notes. To give a gist, basically what happened is prior to 3.0, prior to Android 3.0, the bitmap memory actually had to be managed natively. So as you said, you were responsible, like even though the Android VM, the Android OS knew about like the different allocations that were going towards a bitmap, you were completely responsible in sort of like releasing those bitmaps. And a common way you would do that is by calling the bitmap.recycle method. Mm-hmm. But clearly this wasn't working out. And I guess they noticed that this was probably not the best way to do it. I believe it was after 3.0. Basically, the VM was in charge of taking care of this bitmap recycling. So that you would think that's a good thing, but again, the problem is because you didn't have too much control about when your GC would kick in and sort of like garbage collect the bitmap memory object, it was a little tricky. And if you have a bunch of bitmaps, the larger your bitmaps, then obviously the larger the heap and the more GC is going to happen. So that's always a big problem. So that's something that you should watch out for.
Definitely, yeah. It's the memory situation with Android and bitmaps has always kind of been a quirky one, even since back in the 1.6 days. So it's just, it seems like it's ever evolving, along with the camera APIs are ever evolving, and hopefully things get a little bit better in the future.
Yeah, and I mean, some of these problems are just the nature of the beast, right? I mean, for example, your bitmap, it's a good thing that they're allocating it along with your other VM heap, but it comes with certain trade-offs. So it's important to understand the trade-offs and accordingly sort of build your app. Mm-hmm. Yeah, so like we were saying, reusing bitmaps is a good idea. And typically the way you would do this is there's this object called the bitmap factory options, and it takes in a parameter called inBitmap. It's inBitmap. That's basically what it's called. And you would point it to the existing container that you had. Now, another quirk, previously, before the Android Lollipop, the problem is these bitmap containers that you had, the sizes had to match precisely. Yes. So the width and the height had to match precisely. If you didn't provide a bitmap container that matched the size, then it would be no use. You aren't reusing this bitmap container. I think I think it's KitKat. After 4.4, what's basically happened is that they've allowed smaller bitmaps to make use of this concept. So if you have a larger bitmap and you're using that as your container, even if the actual image that you have is of a smaller dimension compared to the one that you provide, then it would still work, which is nice. But in any case, again, this is only from 4.4. I noticed a very nice link, and this was given to me by my friend Danny Roa. It's a blog post from booking.com. So we'll add a link to the show notes, and they talk very specifically about this concept of recycling bitmaps. So that's a nice read. So people should definitely have a look at that.
Definitely. Yeah, I don't think I've seen that one, so I'm interested in taking a look at that. The bitmap stuff is crazy. And so like you said before, you can use the bitmap and bitmap stuff to reuse bitmaps. There's also other ways you can to help save on memory, and that's to downsample the bitmaps. So this is huge for reducing your out-of-memory exceptions on older devices. So the thought process is you can basically load a higher resolution image and display it as a thumbnail easier. Now, if traditionally what most new developers are going to do is they're going to get an image, they're going to put it in their assets folder or their resources folder, and then they're going to load it in and show it in an image view, and perhaps they're going to set the layout width and layout height to a smaller view so they can have what they would think is a bitmap that's a smaller one, but it's actually the same full-size bitmap. And all of a sudden you've got this huge image that you're trying to shove into this small square peg hole, and all of a sudden, boom, all of your memory's gone. You have an out-of-memory exception, and you spend the next 4 weeks trying to figure out why that is. So anyway, so you can actually do that with you can fix that problem by downsampling the bitmap. And so the bitmap factory has some options that you can do that. So you can actually tell it the resolution that's going to be displayed versus the resolution that's actually of the actual image size itself. And so that does help a little bit. So if you're interested in that or you're having that problem, take a look at the bitmap factory options to help downsample the bitmap. And I know, Kaushik, you've actually worked with something called inSampleSize, which I haven't really touched that much in detail. Maybe you could touch on that a little bit.
Oh, yeah, sure. So basically, like you said, downsampling a bitmap basically points towards like reducing the resolution of your image, right? So if you have a dense image with a whole bunch of pixels, so what you could do is probably reduce the resolution. And the way you do that is with this bitmap factory options. It's called inSampleSize, and it takes in certain values. So I believe these are of the power of 2. So if you pass a sample size of 1, basically it's the source of the native resolution. So if you pass in sample 1 for a huge image, you're not doing yourself any good. If you pass an option of 2, what basically happens is it halves both horizontally and vertically. So along the height and the width of the images, it reduces the sample size by 2. So your image goes down by a quarter of the size. It isn't just 2. So this is something that you have to like understand. If you pass in sample size of 2, it's going to like chop it down by 1 by 4. It's interesting to know that it takes only powers of 2, and there is some basic math. Like we'll add a link to the show notes. The developer docs has a very good, I mean, if you're feeling lazy, you can just copy paste the method. It gives a nice mechanism of calculating the in-sample size, because there's no point in providing an in-sample size of 3 or 5. So there are certain conditions when you want to do it, because assuming you have a source image which is actually sort of like equivalent to the size that you want to show on the screen, or even lesser, then you don't want to like pass in an in-sample size of 4, because what will happen is like the image will get degraded even worse. So you have to be slightly careful about these calculations, and the developer docs give you a nice way of doing that. They compare your target dimension. So if you have a target width and a target height, depending on the target dimensions that you provide and the dimensions of the source image, they try to find the best match for this in-sample size, and they provide it to you. So that's a very nifty technique. And again, if you're using an image library, you don't have to go through these things. But if you don't, like for example, if you have to deal with the camera stuff, then you definitely have to get a good grip on these sort of concepts. So we'll add a link to the show notes. That's also a very interesting concept that people
definitely
find useful.
Now, another way to also to do this is also to work with the cache itself. Now, there's many different ways we can work with cache: LRU cache, disk LRU cache, etc. Have you worked a lot with the cache at all?
So initially we did use, we had like a custom implementation of an LRU cache, but then Jake Wharton came up. He has like an open source library for a disk LRU cache. Now, before we do that, we should probably touch briefly on what, and for those who don't know what an LRU cache is, an LRU cache is the least recently used cache. Now, this is basically a computer science concept. So like for those interested, you can maybe have a look at the Wikipedia article. We'll provide a link to that as well. Android comes with an object, with a class called LRU cache. So you don't have to deal with implementing an LRU cache on your own. You can use the object directly. So the advantage of using an LRU cache is that if you call an object from the LRU cache, then it gets pushed up in priority. So it's recycled much later. And as you keep adding in more images into your cache, or any object for that matter, not just images, if you keep adding bigger objects into your cache, what happens is as an object becomes less used, it drops off the cache. So it's basically a nice mechanism of caching. Now, if you use an LRU cache, the problem is typically most implementations you find online would have it as an in-memory object, which means the minute your application is closed or your activity is recycled or the container object goes away, then the LRU cache goes away. So that's also a big problem, because assuming you pause your app and then you resume the app again, then boom, your LRU cache is gone and everything has to you'll have to start building the cache from scratch. So in order to avoid this problem, Jake has this open source library, which is a disk LRU cache. So what happens is the LRU cache is written to disk, and this allows you to sort of handle situations where like if you pause the app and then resume the app, then your disk LRU cache handles this. So that's a nice technique. Before people use an LRU cache, they used to use basically soft references or weak references of a bitmap cache. Now, this is not really recommended. Like even the developer docs say that you probably shouldn't do this. And the reason you shouldn't is because after API level 9, the garbage collector has become a little more aggressive about collecting soft or weak references. So the benefits that you get towards using an image cache with the soft or weak reference is lost. So an LRU cache is the way to go, and a disk LRU cache is even better.
Definitely, completely agree. LRU cache is something that for a long time I didn't work with, and then we did implement at a couple of clients that I had and had some great results with it. So if you are looking for caching, definitely look into the LRU cache. Another thing that you also will run into sometimes when you're working with bitmaps is sometimes processing them takes a little bit of time, and you don't want to use all of that UI thread time by processing images. You might get an ANR, application not responding error. So a lot of times people will start doing something inside of an asynchronous task, which unfortunately has its own huge set of issues as well. And a lot of times you want to do something like this when you have maybe a large local image in your resources folder, or maybe you're even downloading an image from a remote URL. You got to go get the image, pull the bytes down, save it somewhere, put it in memory, wherever. So you want to do that in an asynchronous task. And so you can get that image, you maybe need to decode it, you may need to resize it. You can finally then set the image bitmap on the UI thread on the post execute. That will make scrolling a little bit smoother, but you're still going to run into some other issues as well with list views, and maybe the list view item has gone out of scope, and then all of a sudden the image is populating the wrong image view at the wrong time. So you kind of run into a whole bunch of problems as well. And an important side note, recently I think it was a DevByte that came out for the performance tips that came out. There'll be a link in the show notes to that. In 60 frames per second, which is basically what we're aiming for here, we essentially have 16 milliseconds per frame to do our work. That's not long at all. And so the garbage collection can take 2 or 3 milliseconds of that as well. So now maybe we're down to 14, maybe 13 milliseconds to do all of our changes inside of a bitmap that we're looking to do. So you definitely want to keep that off of the main thread at all possible, because we don't want to create any more jank inside of the application. So you have to think about any type of image processing as maybe a task that could take up a long time. So think about doing it on a different thread.
We touched upon image, like you said, some of the work that we do to process images. Then there are also like cases where you have to do image transformation. So you want to touch upon that, Donn?
Yeah, sometimes you've maybe loaded the Google Plus application, you maybe loaded MyFitnessPal, or even Square even does this too. A lot of applications will show avatars that are circles, and so as you know, pictures are not taken in circular format; they're taken as rectangles. And so we need to provide some type of transformation to actually I know, crazy, right?
Yeah.
You need to have some type of transformation applied to that image. And so we don't want to do that on the main thread. So we're probably going to do this on a background thread. We may need to run some circular transformation on to create a circle. We may want to fade the image. We may want to overlay it onto something else. We may want to do something, or maybe even apply an animation. So when it loads, it slowly fades in, or maybe it shoots in from the left. And so we need to build some type of transformations. And so again, these things are all, everything we're talking about here are all some of the common bitmap techniques that people use and have used with or without libraries. And so image transformations are a very popular one, and it's usually nice to be able to bolt these on, which we'll talk about here in a little bit with some of the libraries.
Right. So apart from that, there are other things also that you'll have to handle if you're doing all of this on your own. For example, if you want to handle different formats, what if you had like a JPEG, a PNG, a GIF or a GIF, depending on how you want to pronounce that. There are a bunch of different formats that you would have to otherwise handle. And like you said, if you want to show animations or you want to do certain things, another very interesting thing is to be able to have callbacks. So what if there was an error when your image couldn't be downloaded? Mostly you would like to show maybe an error icon or notify the user through some fashion. What if you wanted to be able to first fetch all your images, and then after all the images have been fetched, then you want to, in the form of a callback, display the images? Or if you wanted to add certain filters, for example, if you want to add a slight tint like a color tint to the image before it's actually shown. So all of these basically can be handled pretty well if you had like some mechanism of having callbacks to the various steps when your image is loaded. So these are some of like the techniques these are some of like the requirements and the techniques that you would have to do. And just imagine if you have an app like Wedding Party where you basically are almost always showing a nice image to the user. All that boilerplate, all the things that we talked about, like being able to recycle bitmaps, being able to downsample bitmaps, all of these things have to be done manually for every single image that you show, which can be extremely tedious and it can wear you down. The boilerplate can just totally wear you down. And this is basically where image libraries come into play. So now that you've understood the different nuances to rendering images in an Android application, now let's sort of like step in and see the different options that are for us to use image libraries and how these can help.
Definitely. So yeah, I think that's the big question here is like, what are the different image libraries out there? Today, we're going to talk about the most popular image libraries out there. Again, this isn't in our experience and from what we've noticed through our time working with these image libraries and our time on Stack Overflow and working with the community. Some would agree and some may disagree. Some people may never use any of these libraries, but these are probably the most popular ones from what we have seen. And the first one that I'd like to talk about is kind of the reigning champion, in my opinion, is Picasso. And this is from the guys over at Square, or from the team over at Square, excuse me. And Picasso has a bunch of advantages, and what it really has is the cleanest API, in our opinion, that is. So it really makes it easy to load an image into an image view. Literally, you use some static methods saying Picasso.width, and you provide a context, so Picasso.width context, maybe you're in an activity, put this, .load, provide a URL or a path to a resource. So load this, image resource. So again, if it's a remote image, you can actually tell it'll actually download it in the background for you. Load this image into a particular image view. So I just chain the calls together and it takes care of it for me. It's got built-in caching, which is really phenomenal. I can take this simple one line of code. I can then load in images from drawables, from resources, from remote URLs. I can do a whole bunch of stuff. It's really nice because it's really razor focused on loading images. Nothing really else. That's what it does. It's a super small package in general. It's got around 850 methods, and it's only 24 classes in total. So it's a really small API for working with images. Again, it's backed by the guys at Square, which are kind of the Android open source reigning champions, it seems like. Have all kinds of stuff out there. It's super easy to integrate using Android Studio. Just drop a Gradle dependency into your file. Boom, you're up and running to go. It's really easy to integrate. You don't have to use any custom image views like other libraries or requests that you do. You just drop in the library and say, hey, load this image into this location here. Now, also transformations like we talked about before, where we have these avatars that are circles, or perhaps you want to take something and turn it into stretch it out, or you want to do something with the image in general before you show it to the user. Transformations are insanely simple to write and reuse inside of your application. You can simply write this transformation as a class, store it as a Java file, and then you can use it all over inside of your application, which makes it really, really great. Now, Picasso is again, my usual go-to. It does have a couple of disadvantages. Some people really like GIFs, and some people want to load those GIFs into their application, and Picasso doesn't support GIFs at this time. And it doesn't have as many features as other libraries like the newly released Facebook Fresco library, which we'll talk about, and also Glide, which we'll talk about here in a second. So it's very, I think the major core win for Picasso is it's very tightly focused on what you can do with images and caching and so forth. And you can extend certain things with OK HTTP inside of it to use different clients. And you can really dig into that, and that's available on their site. You can check it out, and that's also in our show notes as well. One of the huge advancements recently is the Fetch API call. Now, Kaushik, have you worked with that Fetch API call? Because I haven't really done any work with that.
Oh, yeah. The Fetch API call is amazing. So what it basically does with Picasso is, assuming you have 4 images that you want to load one after the other, right? So I had a requirement with the wedding party app. So we have this sort of animated slideshow that we have. So you'll take 4 pictures in your photo booth, and you'll want to show each of the pictures one after the other. Now, the problem is, again, you don't have too much control about how these images are downloaded from the back end. So if you have 4 images, what if image 1 downloaded first, then image 4 finished downloading, and then you have image 2 and 3? Well, typically you want to be able to sequence this in some fashion. Mm-hmm. Ideally, what you would want to do is you would want to wait just a little bit, make sure that you have all of the images downloaded locally, and then show them one after the other. That just makes it a much nicer user experience. This is, of course, given that you don't already have all of the 4 images right away. So if you didn't have this fetch call, what you would have to do is you'll have to load the first image, that'll show up, and then as you proceed to the next image, it'll sort of show the spinner again because it hasn't downloaded the second image. That'll pop up, and then it'll pop the third image, and then it could lead to this sort of very inconsistent way of showing images. Uh-huh. But this fetch API call, which I should add, they added it pretty recently. I think it was either 2, 3, 4... their version, it was version 2.4. It's sort of a more recent addition to the Picasso library, and it's basically just a fetch call. So it gives you a callback. The minute all your images have been fetched, or an image has been fetched, it gives you a callback saying, hey, I've downloaded the image. The image is ready now. Now go ahead and do what you want to do with this. So that is very useful, especially if you want to sort of control the way that the images are shown to the user. I just want to also add another big advantage, like you mentioned with Picasso, is it's very easy to start. Assuming you're just sort of trying to test the waters with all this image library stuff, then Picasso is amazing, like you said, because it's very simple to add. You don't have to do anything else. You add the Gradle dependency and you're good to go. You can try it out with one small. So if you have a huge legacy app that you slowly want to transition to using an image library, then Picasso is a great option because you can sort of try it out with a single screen, use it on one image, and then if you like it, which I'm pretty sure you will, you can slowly transition the rest of your app. So that's one huge advantage to the simplicity towards Picasso's API.
Definitely.
Picasso has, so again, like we said, there are different ways to handle your bitmap allocation. There are different concepts. The sort of ideology that Picasso has taken is, assuming you point towards an image, it basically downloads the full size of the image and stores the full size in your cache. Now, if you want to show maybe a different size image on your screen, then what it does is it basically loads the full image, but it uses the GPU to sort of do real-time sizing when it's actually drawn on the screen. So it consumes lesser memory than if you actually show the original bitmap, but it still consumes a little more memory because each time it has to sort of use the GPU to do that real-time sizing. Now, you can avoid this if you basically have 2 calls. If you use the call to fit and then maybe a center crop or a center inside, then this dramatically reduces the bitmap sizing. So if you tell Picasso, hey, I want it to be of a particular size, then it basically uses that instead of the source call. So there's another API that Picasso has, which is basically resize. And again, if you have wrap content, but you specify the exact dimensions in your resize, then Picasso is intelligent to understand that, okay, that's the dimension that you want to store. So these are just some things that you should note. There are I wouldn't call this an advantage or a disadvantage, because what if you had maybe a screen where you basically show the user's picture at four places? You have an avatar size one, which is pretty small, like a thumbnail, but you also are in a profile page where at some point you want to show the full blown image of the user. In this case, if you said, oh, well, no, Picasso should be storing only the precise size that it actually needs, then in that case, it's going to have multiple versions of the same image in your cache, which again doesn't seem like the right fit. So depending on your use case, you can sort of handle this differently. So this is why it's a little tricky on deciding which bitmap to cache. Either you store the original size or you store multiple copies of the same image but at different sizes. So it's just something that you have to take note of, and depending on use case, be able to control this with depending on the dimensions or the sizes that you're showing.
Definitely. I think it's also important to note before we wrap up Picasso that personally, for me, Picasso is my go-to image handling library. It's always the one that I reach for first, and it fulfills the majority of all the use cases that I run into with Android and images.
So Picasso is amazing, but another new... Well, this is actually a relatively new kid on the block. There are newer libraries, so it's hard to call this library the new kid on the block. But Glide is another library that's been picking up a lot of steam. Mm-hmm. Now, there's this blog post where it had an interesting name. Oh, yeah, it's the blog is basically In the Cheese Factory, and they've done this amazing comparison between Picasso and Glide. So if listeners want to have like a detailed, in-depth look, they can look at that. But Glide is a library which was basically built with the primary focus of making scrolling on any kind of a list of images super fast and super smooth. So the library Glide is very aggressive about like reusing bitmaps, caching the images. They do a lot of these things, and they try their best to make sure that image loading is as jank-free as possible. That's like their primary focus. So they make certain assumptions, and they've taken certain decisions for their primary defaults that we'll quickly touch. I tried Glide initially before we had a Lollipop, just to sort of like get an idea. And I must say, on our timeline, when I used Glide, like it was immediately evident that the scrolling was far smoother.
Really?
So oh yeah, definitely. Glide does a really good job. The problem is it is a newer library compared to Picasso, which means it's not as battle tested as Picasso. So there are some bugs around. Again, I haven't used it. I'm also primarily a Picasso user, so maybe a bunch of those bugs have been ironed out. Another interesting point to note is that in the most recent Google I/O app, Glide is the library that they use for their image loading. So it's sort of gotten the indirect blessing of Google to that end. It's been used. I believe it isn't officially from Google. No, it's definitely not officially from Google, but it is sort of gotten the nod or the blessing of Google in some way. So Glide it's pretty useful. Now, Glide has more features than Picasso, which means obviously it has a higher method count, and it's a larger library than Picasso because it also gives you certain extra features. One really cool feature of Glide that I liked is it has this sort of blur effect. So assuming you point to multiple images, and as the image is downloaded, what do you do until then? So you could maybe show like a spinner or an opaque background, but Glide basically, it does an intelligent thing where it sort of like tries to stream the data as it comes in. So it'll sort of have this blurry effect of the images, like as the data comes in, it sort of like quickly puts that up. So it gives you the perception that it's a little faster because it's slowly pulling in, giving you an idea of the image even before it's fully rendered to its complete sharpness. So this is a really cool feature that I found, and it comes almost completely for free. You don't have to do anything. You just point to a URL, and this feature comes in for free. So that's something cool. It's pretty cool. It also supports GIFs. So that's a huge win. So assuming your app, you need to show GIFs, then Glide is a good option. If you point it to a video, so this, I haven't tried this myself, but this is on their feature page. If you point it to a video, then basically it gives you like this option for showing video stills. So it doesn't actually render the video, obviously, because it's an image loading library, which is very different from a video. But it at least, I think it tries to download the first frame from the video and renders that as an image. So that's also a pretty cool feature to have. Like Picasso, so I believe many of these libraries, their APIs have been inspired by Picasso. So it follows almost exactly the same API of Picasso. So if you feel very strongly about having a nice and clean API, similar to what Picasso has, then Glide also sort of like makes sure you have that check mark for you. It's very easy to integrate. Like Picasso, you don't have any of this custom image view stuff that you require. It's all modeled very similar to Picasso. Another interesting feature with Glide, as Donn was mentioning, when you actually have the call to Picasso, you would have like Picasso.with and you provided a context. What Glide does is it basically it gives you an option to provide an activity or a fragment specifically to your context. And you should actually do this. Don't just think it's like a default context that you need, because by providing glide specifically with an activity or a fragment, it sort of understands the life cycle. So if you have a fragment and an image lives only in the life cycle of the fragment, then it actually respects that, and it does some intelligent caching. So if that fragment goes away, then I believe the image also goes away from that cache. So that's a pretty cool and interesting thing to note about the usage of glide. It also has transformations, and it's actually pretty cool because you can actually use the exact same Picasso transformations that you have inside Glide, and that's, I think, one of the features. So if you've built this huge sort of library of transformations over time in your app, then you can quickly switch from Picasso to Glide by just using the exact same transformations. So that's
cool. That's very nice.
Yeah, that's one interesting feature. We didn't actually specifically mention this, but Picasso doesn't actually do bitmap recycling. It does bitmap caching, which is a different thing from actually reusing the same bitmap containers. Now, we'll add link to the show notes. Glide actually does bitmap recycling as well, but Picasso doesn't. And this is sort of more of like a decision that was taken. We'll point to one of the GitHub issues where Jake Wharton mentions clearly why, like his stance on the subject, why he hasn't done bitmap recycling yet on Picasso. There's a lot of interesting details and based on the decisions of each of the library maintainers. So we'll add link to both of those in the show notes. Now, things aren't always as rosy as you would like them, because clearly the features are really good with Glide. As I mentioned initially, one of the problems I noticed was I couldn't really use Glide because I believe it's sort of, and I don't know if it's fixed at this point because I used Glide right when it just came out around the initial periods. One of the problems with my usage with Glide was basically since our app has a lot of information embedded with images, we used the tag. So every view inside Android has this attribute called tag where you can sort of store metadata. Yeah. So you can store information on the tag. I believe Glide uses this tag critically for some of its strategies for caching the bitmaps. And so I noticed that because I already had some data stored on my tags, it didn't do for some reason it would either freeze or it would not show the bitmap. So this was a bug that I had early on. And I mean, just because of the nature of the way the caching was done, it was a problem that I had. Again, I'm not too sure. This could probably have been fixed by now, but it was something to note. Make sure you don't want to whole hog just suddenly switch to this library without sort of watching out for some of these quirks, which might be a deal breaker for you, because it was sort of a deal breaker for us. We just couldn't use Glide because we had to have that information stored. Because it's a bigger library, clearly there are more methods, and anytime you use a library, you have to watch out for the DEX method limit count these days. So I believe it has almost 2,700 methods, which is way bigger than Picasso. So that's sort of a ding. But again, if you want more power, then you're going to need more functionality. It's an unavoidable problem. You're going to have an increased method count. But it's important to note that.
I agree. Now, for the tag problem, I wonder if that's been fixed. And I know with the tags, there's various ways you can use a tag. There's the default tag, which is just the object, and then you can also provide a keyed right. tag as well. Were you guys using the keyed tag, or were you just using the object?
I believe I tried both options.
Yeah.
Initially, I ran into the problem, then I changed to a keyed tag, but I believe that still was a problem.
That's interesting.
Let me try it. I think I raised a GitHub issue on this on the Glide library as well. I'll try to find that on the show notes and point users to that. That should actually, it would be very helpful to, sure. If it was fixed, then I'm pretty sure that issue was closed at this point.
But yeah, if we could, it'd be great to find it. And then if users are, because I know there's a lot of people that use tags, such as myself, to store additional data for the view. So definitely would be helpful if we could find that issue. Yeah. So I
should note though that tag is only for the image view, because the tag, the strategy of using tags is super common in list views. and the view holder, the whole view holder concept, which before the recycler view days, like this is a very common technique that you would use. It isn't just, I must mention, it isn't about tags in general. It's only the tags on the image views specifically.
Definitely. So now now there's a disadvantage that some people might find this as an advantage or disadvantage. I kind of put it in the disadvantage column. And with Glide, what happens is that Glide defaults to an ARGB 565 format, and which by default Android uses the ARGB 8888 format. Now, the 565 format has a lower memory footprint, so that is a benefit because it does take lower memory. And you can see that in the blog post that we have in the show notes where they actually show a graph saying here's how much memory Picasso takes compared to how much Glide takes. Now, I came from a background, and as I said in a previous episode, I used to work for a comic book company, and so every image that I always worked with had to be super high quality. That's just what people wanted. They wanted to see really high, crisp images. And that seems to be the case nowadays with people with these Retina displays, and each device is getting more pixels, and everything is looking more crisp and more crisp. And so the lower memory footprint does come at a cost, though. And so what happens is the quality of the image actually gets lowered down. And so it's basically uses less memory because it's using 2 bytes instead of 4. And so we also don't have any transparency as well, which is another issue. So I feel that's kind of a downfall. From my perspective, I like to get a high quality image so it looks how I expect it to look. And then if I decide that for some reason that's okay for me, or I need to provide a lower image to the end user, I should be able to configure that. To me, it feels a little bit backwards. Other people might feel better that, hey, I get more performance. So that's better for them. So I think each person is going to have a different take on this. I just decided that I thought it was in the disadvantage column.
Yeah, they do provide an option, however, to switch the default format. The default format is RGB 565, but they do provide an option where you can change it to ARGB 888. So that's worth noting as well.
Yes, exactly.
Another thing is it requires the support library. Again, we don't want to call this a disadvantage because, if you're developing an Android app today and you're not using the support library, I would be very, very surprised. Yep. So it requires the support library. So that's, again, something you should note. And I guess we've covered most of the stuff. Like as I was also mentioning about Picasso, where it caches only a single source size, Glide takes the opposite side. Glide actually does sort of recognize each image as being different. So if you have 4 sizes of the same image being shown across different screens in your app, it actually caches 4 different independent images. Now they do give an option again, like you can use a different cache strategy, and I think the API call is just like .disk cache strategy, and you can say cache all, at which point it would store the source image. It would store like the original resolution of the image and then accordingly sort of resize it and show on the screen. So that's also something to note.
Mm-hmm. One final thing that's important to note is a tweet showed up a couple of weeks ago back in late March where someone asked Jesse Wilson, and for those of you who don't know Jesse Wilson is a member on the Square team. Someone asked him, basically, what do you think about Glide compared to Picasso? And his answer kind of sums it up really succinctly and perfectly. And he basically says, and I have a link for this in the show notes, it says, it's Coke and Pepsi. They're more similar than anything. Glide has more features. If you need them, use it. If not, you don't, use Picasso. And so that kind of sums it up how I feel too. So if you need Glide and you want these features, then use it. If not, then you can always default back to Picasso.
Yeah, that's very well put. Jesse Wilson is a super smart guy. Again, I always I have this picture of like the coffee machine in my head when anyone talks about Jesse Wilson. And this is because one of the initial sort of tutorials or like the screencasts on Dagger was presented by Jesse Wilson, in which he talks about how like he sort of uses the metaphor of a coffee machine to explain how Dagger works.
Yes, Jesse's insanely brilliant. Okay, HTTP, Dagger, you name it. If the guys at Square and Jesse and Jake have just put a whole bunch of stuff out. So On to the next library. The next one is Ion, and this one I've seen used quite a bit in applications. It's been around for a while, and so a lot of people are familiar with it, and it's kind of their go-to library as well. And Ion is actually a comprehensive library which includes like a networking stack too. So it's kind of an all-in-one package solution. Unlike Glide and Picasso, where Glide and Picasso mainly are highly focused on just dealing with images, Ion also does other stuff other than images, which is you can download JSON, you can do a whole bunch of other stuff. And so we're just going to touch on mainly the image aspects here. And so some of the advantages that Ion has is it supports the disk and memory caching, which is kind of nice. The bitmaps are also stored as weak references, so memory managed very efficiently. However, we also spoke earlier how weak references are also collected a little more aggressively with the more recent versions of Android. So that could possibly be a problem. I'm not sure. I haven't used Ion, so it would be good to research it before you do make a switch if you're interested. Of course, by default, it supports list views in the same fashion that other image libraries have supported them. Supports transformations, their own type of transformation, so you can provide those circular avatars or whatever you might use. There's no additional image library that's required on top of Ion since it kind of does everything for you. And it also kind of follows Picasso's API pretty closely. So if you're familiar with that chaining, you can do it. One nice thing, though, is it does support animated GIFs, again, for those people that really like GIFs and want to show them. Now, the real big one that I see, and I'll actually use Ion for when I do need it, is the ability to perform deep zoom on very large images. And what deep zoom is I'm sure you've been to a website before where they show you a picture of London. You're like, oh, that's a nice picture of London. And then it says, well, like, now zoom in. And you zoom in, and then the image quality gets better. You're like, oh, wow, that's cool. I can see that building. And then you zoom in again, and all of a sudden you can kind of see a car down on the street. You zoom in again, and all of a sudden you see a guy on the street, or a person. And you could keep zooming in, and eventually it's like you're almost reading a license plate from this image that was originally taken from the sky or from space. And so these are like these deep zoom images, and Ion supports that. And through just one configuration option, just saying, hey, this is a deep zoom image. And how that works actually is in Android, there's something called the bitmap region decoder. And what that is, Deep Zoom uses that to actually enable this deep zoom. And what it does is actually decodes regions of the bitmap. So it kind of breaks up the huge image into chunks. And say, all right, well, I need these 4 chunks, and it decodes those 4 chunks with some given parameters. It allows you to actually, as soon as you zoom in, more of the regions are decoded. There is a video that we all have added to the show notes that shows you exactly how this works. And it's interesting because you can actually see through some flickering that you can watch in. I think it's the debug setting that does this. Flickering that you watch, where you can see the actual squares loading independently, and those are the different bitmap regions. So that's very, very useful. It also supports animated loading, so you can actually animate some things in and out and so forth. Mm-hmm. Now, Kaushik, I know that you really liked Ion because it supported some features that you liked, like futures and so forth. Is that correct?
Oh, yeah. So basically, Ion was the very first image loading library I used before actually Picasso. So I've used it a bunch in the early days. I must say it's an amazing library. It follows the APIs very closely to Picasso. It follows Picasso's APIs very closely as well. So it was very easy to use. And like the advantage, like you said, is like some of these, like you get some of these amazing, mind-blowing image features just for free by calling one attribute. Futures was something that I found very interesting. Now, this is before my RxJava days. So before I even came across RxJava, Java in itself has this concept called futures, which basically works something very similar to the observable pattern. So what it basically says is like, oh, okay, I'm not going to execute this bunch of code just yet, but here's a return type. So you can presume that you have this return type and then go on to doing subsequent operations. And in the end, you can say, okay, future.get. So it's sort of almost like an object that allows you to sort of postpone actions. And I found this very useful in the early days, especially for networking stuff. So I could say, okay, I have 4 of these calls and each of them would return a future. And based on each of these futures, I'll perform a specific action. So these days, because I've been more interested with RxJava, I use RxJava for most of these things. But for someone who's not really too much into RxJava yet, this futures provides a very nice alternative specifically for using the network or even images for that matter.
Definitely. Yeah. So it does support, like we said before, it does support other networking calls, and it can act as an all-in-one library if you like that sort of thing. So that can be an advantage. But I think some people might also consider that a disadvantage. They may only want this for the image loading components. And so you have, some people might consider it a little bloat in the library because it's an all-in-one solution for networking, image loading, and so forth. So
my line of reasoning was that these days I just cannot do without retrofit. Retrofit just makes things so much more easier, which is basically the network client library that Square has. This is, again, retrofit is a wrapper on top of the HTTP client, HTTP. So we're not going to go into the details there, but retrofit was so powerful that I just could not use retrofit. So because I used retrofit, then I was like, at that point, Ion seemed to be slightly bloated, and it was doing too many things. I didn't really want as many features that Ion gave. But hey, I mean, if you want a single library that just does a whole bunch of things for you, and you don't want to dissect every single library and sort of use them for like a specific function, then Ion is a good option for that.
I definitely agree. And I think maybe the other disadvantage is it does have limited functionality when you compare it to some other libraries. It does a few things, and it does those things very well. And so if that's all you need, then you can go ahead and use this library. And I think Ion has a lot of positive benefits and just a few negative ones. And each library, again, is going to be for each individual use case. So feel free to use it if you like it.
Yep. Along the same lines, there's also another networking library that does image loading very well, which is Wally. Now, unlike Glide, Google actually does support Wally. Wally is direct from Google, so it isn't something that's just like given the nod or blessed. I believe Wally is directly from Google. Again, I want to preface anything that I say with this statement. I haven't, because people can get mad if you say things that about libraries that they hold dear, right? Mm-hmm. I haven't used Wally a whole bunch, so take anything that I say with a grain of salt. But my first, I did look at it initially. Now, there is a Google I/O video, and this is by one of the Google engineers, Ficus Kirkpatrick. It's actually an amazing video. You should see it. And when I saw the video, I was really impressed because it talks about doing some really powerful things. It isn't just an image loading library. It is very similar to Ion, a complete full-blown networking library. So I saw the intro video and I was very impressed, and I wanted to try it out right away. And as I hit sort of each step, I was trying to how would I perform action A? How would I do action B? Is feature C present in this library? Immediately, you'll find that the documentation, at least in the early days, the documentation was not just terrible, it was non-existent. There wasn't any documentation, and that immediately turned me off. One of the advantages with companies like Square is they're very diligent about maintaining their open source libraries. They have very clean and clear documentation, and especially if it's a new library that you want to try out, having good documentation is a big win. And unfortunately, that is one primary disadvantage with Wally.
I had the same thing happen for me when I ran into Wally. I saw that same video you saw. I thought it was amazing. I went in to go take a look at it a couple of days later to possibly pull it into my app. I got down into one of the method calls. It didn't make sense to me. I asked a question on one of the social forums or a chat somewhere, and I think someone replied back, "Oh, for that you need to go read the source code." And as soon as I saw that, I just said, "Forget about it," because a lot of the times, I don't mind reading source code because I learn a ton and I do it a lot. But when I'm building a product or I'm building an application, I don't have time a lot, unless I'm running into a huge problem that I have to break through, to actually go and learn about a new library by reading the source code. And so that documentation really is key. So I completely agree with you, Kaushik.
That being said, there are some huge advantages to using Wally. One is I'm sure it's as battle tested as it gets because, again, Ficus Kirkpatrick, the Google engineer that I mentioned, he works on the Play Store app, and I believe the Play Store app does use Wally, and a couple of other Google apps also use Wally. So clearly, it's battle tested because those are some of the biggest apps ever used in the Android Play Store. So given that, it has a huge backing, and that makes a lot of sense because clearly it is a library that you can use reliably. Another advantage, like Ion again, is you don't need any additional sort of libraries for your image loading. It does image loading pretty well. But most of what I've read online points towards Wally having very powerful sort of network downloading characteristics. For example, you can prioritize and queue up network connections. And I believe he also mentions in the video, it sort of does this automatically. It has like this sort of intelligent queuing and prioritization mechanism for your network connection. So that's a huge win, if especially you don't want to be dealing with these things on your own. There are, again, certain disadvantages to using Wally. For example, it generates a lot of garbage when you're handling large responses. So because it has an opinion on the way it sort of like renders bitmaps, if you have like huge bitmaps, like I remember reading this somewhere in a comparison on a blog post that sort of compares Wally with another image networking library, that it generates a huge amount of garbage, which can be a problem because that basically means there's a possibility of it chunking up your UI. Another big problem is it doesn't come with an image caching mechanism out of the box. Now, again, there's a little nuance to this. It gives you the option to sort of provide it an implementation. So you can say, hey, Wally, use this mechanism. Here's my LRU cache or my disk LRU cache that you should be using. And with that, it basically uses an image caching mechanism. But right out of the box, it doesn't come out with an image caching mechanism. So that's something that you have to note. If you want just like a library where you have zero amount of work to be done, well, this isn't necessarily, you should watch out. There is like some amount of work.
Now, you didn't use Volley as your primary library, did you?
No, I didn't. Again, and this goes back to retrofit. Retrofit is just so damn convenient that
Yes, it is.
Yeah, and it also supports observable calls now with RxJava. So I would find it very difficult to move away from retrofit. And given that I'm using retrofit for my networking library needs, I just don't see the advantages of using Wally personally. So again, this is a personal opinion. I feel Wally is basically not doing the thing that I primarily seek from an image loading library. So given that, I don't think I would use Wally, but you never know, never say never. But retrofit is like amazing for the networking needs, so I gung-ho on retrofit.
I'm a retrofit convert as well. Prior to that, I used HTTP requests from Kevin Sawicki from GitHub for a few years, and I used it because it was simple and it just worked. Mm-hmm. And I just written a couple wrappers around some of the stuff, but then I had a chance to finally work with retrofit, and it just was like a breath of fresh air. It was so much easier, and when I needed to get into that low level, update some low-level calls, I could just create my own OK HTTP client below and make a few setting changes, and I was off to the races. It was so much easier. Mm-hmm. So anyway, we'll talk about the last library that we're going to talk about today, and that last library is the new kid on the block. That new kid is Fresco from the Facebook team. Now, I'm going to caveat this with that Facebook is full of amazing engineers that are insanely smart. And Facebook is also dealing with a set of problems that most of us will never encounter in our careers. And the reason why I say that is because when you're at the scale that Facebook's at, when your app is almost installed on every phone out there, that's an insane feat. You have you're in a different playing field altogether. You're in a different league than most other apps are together. The only other people out there that are competing with you at this level is basically Google. And that's with Gmail and Chrome and the Play Store and so forth. Other than that, there's not many apps out there that are at the level that Facebook's at. And that said, Facebook has done some amazing things with different libraries. And Fresco is a new library that they've released for image handling in Android. Now, that has a ton of advantages, and the main advantage is, this is a very 30,000-foot view, is that it's insanely powerful. You can do a ton of things with it and have a lot of control to get a lot of performance out. And that's what Facebook's really after here, is to get that performance out. They want to make sure that the scrolling is optimized, that the bitmaps are being reused, the bytes are being reused, the images are not being created and released unnecessarily. They're being utilized appropriately, so you can get that nice fast scrolling. Fresco, I believe, is used in the Facebook app. It's also used in the Messenger app as well. Now, that said, I'm going to kind of hop into a little bit of the details here, and there is a full blog post that introduces Fresco that I recommend that you read if you're interested in it, that explains all this in even more detail. But in short, some of the problems that Facebook ran into is that when they were loading these images, they needed to utilize different, they need to look into how the memory was managed inside of Android. And so they looked at the different memory allocation techniques inside of Android. And so by default, we have the Java heap, which is used by the Java language new operator. So that's where a lot of image data and so forth could be stored. We had the native heap, which is where the C++ new operator stores all of its memory. And then we also have a special memory region in Android called ashmem. And that operates like the native heap, but it's in the Android memory region, and it allows us basically to think of it as like pinning memory and an unpinning memory. Just saying, hey, keep this memory around. All right, I'm done with it, unpin it. And now I won't get into the exact details of what it does, but at a high level, the ashmem allows memory to kind of stay around if it's unpinned, and then the system will only collect it if it's absolutely needed, and then it will clean it out. And then when you request it again, it'll just get repopulated. And so Fresco utilizes a lot of these key components of the memory allocation to actually use the native memory, because the Java heap, we're kind of limited in the amount of memory that we can use. And that's per device. That's actually that's per application. Java heap size is actually set by the device manufacturer. So we can't really depend on this to be unique across each device, unfortunately. And this is kind of a global problem, as we talked about with cameras earlier, that each device has different implementations. And that's the same. And this is not limited to just like memory heap size to the camera. This is everything that's hardware as well. And you've probably noticed this with the accelerometer, perhaps various other sensors that are inside of your device. Each one of these manufacturers use a different component. So that's kind of an area where the iPhone kind of shines a lot, is that all of the components inside the iPhone are usually from the same manufacturer, so they all work the same. That's not the case inside of Android. And so this is the same case here with the memory. So what Fresco is doing is to actually make memory more efficient. They're actually using the native memory and hopping out to use native memory, because you have a lot more that you can work with when you're working with native memory. And so it uses native C++ calls to manage that native heap memory, which gives us that extra workspace in the memory area where we can work. So again, the goal is to just speed up the image access in the heap. And the way that they do this is through ashmem. There's this native called Android bitmap.lockpixels. And what that does is they create this, they get this image, they decode it, and they do everything they need to do. And then they want to save that memory somewhere. So instead of saving it on the Java heap, they save it in the native Android memory location. And
is this like a JNI call by any chance?
I'm not sure if it's a JNI call, and I have to look at the introduction post again. It does describe it a little bit better than I am. I know that for sure. They went really deep into it, but it hops down into a native memory level. And so it's not nothing you have to worry about in Fresco. It's just something kind of interesting to know how it works. Mm-hmm. And basically they call something called lock pixels, which locks the pixels where the image memory lives, and it locks those pixels from being reused anywhere else. And now normally you're supposed to actually call unlock pixels as soon as you're done with the image. Now Facebook actually does something a little bit different, where they actually say they lock the pixels for a period of time while they think the image is going to be in use, and then they call unlock pixels later. And Roman Guy from the Android platform team actually expressed some concern in a tweet that's actually in our show notes, saying that, well, his main concern is I'm not really sure how the lock pixels, the native call works. And so it's kind of a concern for even someone that's on building the Android platform to how this works. Now, again, I'm going to preface this with that Facebook is on a different level. They encounter issues that we don't encounter on a day-to-day basis as regular developers for the majority of companies out there. So that's kind of the low-level implementation. Now, something they also implement inside of Fresco, which is nice, is streaming. Now, this is something that Kaushik, you talked about before. I think Glide does this a little bit, is where the image will actually start showing up before it's fully downloaded. And so it's kind of a progressive download. And so Fresco supports that as well. It has an interface that's very similar to RxJava, but they implemented something known as producers and consumers. And so this allows you to actually perform different operations on the result set that's coming down the stream. So you can actually tell how far the image is downloaded. Maybe you want to provide a progress. Maybe you want to show something else. They have all these hooks in there where you can use that. And it's very similar and inspired by RxJava, which I'll get to in a second. It also supports animations, of course, which we're not really touch too much about that, what it does, fade in, fade out, and so forth. And supports GIFs, of course. If we're using the Facebook app and you want to use one of those animated GIF stickers, you can do that. And also supports WebP, the video format is nice as well, so that's very nice. This is very configurable. You have a lot of hooks into the system. It's a very large library, which kind of leads a little bit into the disadvantages. Compared to other libraries, it's super complicated. Like, if you read the introduction post, I'll be honest. Like, the first time I read the introduction post, I got about halfway down, and I said, no way, man, I'm not doing this.
Yeah, I had a very similar feeling, too. I was like, this seems way more complicated than it needs to be. But
yeah, I just needed to load a couple images from a remote location, size them to do what I needed to, and I could chain those calls together with Picasso or something similar in Glide, but it was too complicated. The one that really kind of turned me off is that they created something known as producers and consumers, and this is, they even state in the introduction blog post that it's highly inspired from RxJava and the Rx extensions. Now, for those of you that listened to the last two shows with Dan Liu, or have even looked into RxJava, you know that RxJava is a complete beast to learn in itself. There's a tremendous learning curve just to grok RxJava. I've been doing it for a while. Kaushik's been doing it for longer than me. And Dan Liu's been doing it longer for both of us. And to this day, we all still run into many issues like, well, here's how I'm doing it. Am I doing it right? Am I doing it wrong? And so we're still trying to wrap our head around everything that is RxJava. And so having something that's inspired by RxJava, but then creating your new thing now just seems like another thing that I have to go learn in order to use this library properly. And unfortunately, that's kind of the case that Facebook has created at this time. And sometimes some people might feel that it's the NIH syndrome at play. And what that is the not invented here syndrome. And so if we didn't build it here, then it's not important. I don't know if that's the case there. I think Facebook probably had looked at RxJava, saw that it maybe did what they wanted to do, but they didn't need the whole stack, and maybe just decided to implement their own version of it. And that's sometimes what large companies will do. And so this is not something that Facebook has just done for the first time. If we look at some of their other apps or other contributions to the community that they provided, you'll see that they've also done this with various DEX issues that they ran into. They had to do some DEX magic where they were rewriting some DEX stuff. Complete like black magic. But
I believe they found again, there are like blog posts about that, but I think they somehow were able to either bypass the 65K method limit, or they were working around it, or they were doing something along those lines.
Yeah, it was really awkward. That's, before you could do the multi-DEX in Android Studio, which I'm sure we'll cover in a future episode. They also created, Gradle wasn't fast enough, Ant and Maven weren't good enough, so they created their own Android build system called Buck. I still have not used it, but it's one of the things they used. They commit so much code that they have scaling problems with Git, which I think they solve with Mercurial, but I haven't really looked into it recently. They've created React, JS, which is very popular, but they created React Native for building native applications with React. And so Facebook is really experimenting on the open source front, but I do have to give it to them that they are very much putting themselves out there. They are pushing stuff out and pushing the community forward with all these contributions. I just feel that the Fresco library is a little too complicated for probably the majority of people out there, but it does give you that flexibility that you may need if you run into these weird situations. If you are using images like them, or you run into the same situations they're running into, this is probably a very valuable option. The last thing to wrap it up is that using native calls to manage memory, in my opinion, seems a little brittle. Anytime I've worked with native calls, I just get myself into literally a heap, pun intended. I get myself into a heap of trouble.
Well done.
And so calling lock and unlock pixels indirectly through the library just seems kind of weird. And even when I see Roman Guy expressing a little bit concern, it makes me a little more worried. And I'm not the guy that's writing Android. I'm just the guy that's writing apps for it. So I think it's a great library. I think it has its use case. It's just not for me at this point.
Yeah. There are a bunch of other libraries also. For example, Universal Image Loader was, I believe, one of the oldest image loading libraries. It's supposed to be very powerful as well, but I have not even looked at the APIs closely, so I don't think it makes too much sense for me to comment on it. But it is, I must say, as the community is sort of progressed, I don't see too many people using Universal Image Loader too much, so maybe that's something to note. So, but an honorable mention should be made because it is one of the initial libraries that gave a huge amount of power to the Android user.
Definitely. I completely agree. So I think, what ends up happening at this point is we've talked about some of these libraries, and people that are listening may be thinking well, crap, I got a whole bunch of options. What do I use? Well, that's a very hard question to answer. And so if you were to ask me, if you stopped me in the hallway here at the office and said, hey, Donn, I'm building an app. I need an image library. Which one should I use? Well, the first thing I'm going to ask you is what kind of app you're building. And the reason why I'm going to ask you that is because I think you need to pick the best one for your use case. You need to use the right tool for the right job. And think of all these libraries as tools in your toolbox, and they all have their own use case. So figure out the best one that's going to work for you. Like I said, immediately I always reach for Picasso. That's my go-to. I pick Picasso. I always recommend it first usually. And then if you need more features, then kind of go down the line from there and choose the one that you like. And if you need that deep zoom for the huge image, then of course go grab Ion. And maybe use them both. But just use the right tool for the right job. What about you?
Oh, yeah. My sentiments exactly. I would always start off with Picasso. And in fact, even right now in Wedding Party, we do use Picasso just because it's small, it's tight, it's clean, it has a nice API, it's easy to use, it's very reliable, and you have complete control. You have a good understanding of what it does. So I always start off with Picasso. I must say, if I do for some of my side apps that I sort of do on my free time and as a hobby, I will definitely try Glide because some of the features are pretty powerful and it looks interesting. So definitely I would touch Glide as well. Again, if you want more power with a networking library, then at that point you should definitely look at Wally or Ion. And yeah, it's so specific to your use case. So you definitely, depending on what you want to use, you should definitely use the one that sort of suits your needs. But I think the overall point is these image libraries are extremely powerful. They're out there. They take into account some of the best practices and techniques that you should be using for loading bitmaps. Definitely use an image library. Don't put yourself through the torture of having to deal with each of these individually unless you really have to for some of the use cases. So definitely use an image library. There are amazing image libraries out there. And yeah, power to you, depending on which ones you want to use. Let's go on and and recommend some of our awesome picks for this week. There were actually a whole bunch of them, so it's going to be tricky, but let's try to distill them to some of the ones that we found super interesting.
Definitely. So this week, like you said, there's so many that came out, and I'm actually relying on three of them. I have four here, and three of them are actually fairly old, but I use them all the time. But the first one is new. And that one's called Moshi, and it's a new modern JSON library for Android and Java from the Square guys. And so they've created a new JSON library. And so I don't even know if it's been really released yet. I kind of bumped into it on accident when I went to Square's GitHub page, and then I heard it 2 days ago on Twitter that Jake had talked about it at DroidCon Montreal. So it should be very interesting. Have you touched it or worked with it at all, Kaushik?
No, I did look at it because, again, like you said, I did notice it on their GitHub page, so I did look at it. But I haven't actually used it. I believe it's sort of like an alternative to either JSON or Jackson, which is basically the reigning champions in JSON parsing for Java. But it'll be. I'm very curious to see what they come up with because I know they use these JSON parsing mechanisms pretty heavily in all of the libraries that they use. So I'm very curious to see what turns out from this.
Yeah, exactly. And this is called Moshi, and that's spelled MOSHI, so Moshi. So the other ones that I have actually are related to working with JSON and kind of just a lot of boilerplate code, really. A lot of times I will find I have a chunk of JSON that's given to me from an API endpoint, and I need to turn that JSON into a POJO. And a lot of times what you'll do is you'll just look at the code and you'll create the POJOs by hand. And it's kind of annoying, really. It just takes a lot of time, and it's really prone to error. You miss something, something's private, it should be public, blah, blah, blah. So there's actually a tool called JSON Schema to POJO.org. And what it does is you take a chunk of JSON or even the JSON schema, drop it into a text box, tell it the package name you'd like, tell it if you're using JSON, or JSON or Jackson is your JSON processor, and then hit generate. I think it's generate. You hit the button below, and what it does, it pops it up and generates your POJOs for you instantaneously. You could tell it to use generics, not use generics, etc. Literally saves hours of time. It's very useful. On that same front, I also do not like implementing parsable. I do like implementing it because it gives me certain things I can use in the app. I can pass the objects around is what I need to do. But I hate implementing it because you're basically, a parcel is you're working with binders at a low level, and you're basically writing bytes into a stream. And that's what a parcel basically is. And to do that, you have to say, parcel.write array or write long, write string, and then you have to read them out in the same order. Otherwise, everything just goes to heck. Mm-hmm. And so, what you can do with Parsable is just drop your POJO definition into the text box, very similar to the JSON schema one. Hit the button below, and then it just gives you your class back, but with parsable implemented properly. So it's very, very useful, and you can actually implement that very easily, very nicely. Now, to take that a step further, if you don't like doing that manual step and you would like to have more maybe code generation, kind of annotation-based stuff to do this for you, there's a tool called Parceler, which will do this. So you can provide an annotation on a field and say, hey, this should be parsable. And what will happen is Parceler will take care of that stuff for you through code generation, which makes it really easy. And those are my picks for the week.
Very cool. Okay, so for my picks for the week, the first is actually a three-part blog post series, and this is interesting for Java developers. The title of the blog post is Not Your Father's Java, and it's basically an opinionated guide to modern Java development. I really liked it because typically when anyone thinks about Java development, they think about dinosaur kind of development in the olden days, because Java is an old language, but this is a very nice blog post series where he talks about the developments in Java. So she or he, actually I don't remember, but basically it's a nice guide where they talk about, what Java is actually more advanced these days. It talks about some of the newer features with the JDK. It talks about using Gradle as the build system. So it was a very nice read that I happened to chance. Another pick for this week is from the Caster.io screencast series. Now, Donn in a previous recommendation made the call to Stetho, the library from Facebook.
Yep.
I'm not sure if you released it this week or the previous week, but I recently saw the Caster.io screencast and I thought it was really cool. So that is my recommendation for the week. Definitely go out and see this screencast that Donn made for Stetho. It was pretty cool.
Thank you.
And my very last pick for this week is actually something that's completely different. I'm basically a ringtone junkie. I like collecting ringtones. There is this site called Cleartones, and I'll add a link to the show notes for this one. It's cleartones.net, and the reason I really like the ringtones and the notification tunes that they have is because it's very professional, it's clean, and it's there's a certain science associated with it because they've actually tried to pick tunes that would be clearly audible and heard in maybe like a noisy environment, but then it's also professional enough where you don't have like a clown shouting or like some funny sounds coming out of your phone during a meeting. So have a look at cleartones.net. I very highly recommend that.
This looks great. I'm going to take a look at that Cleartones one. I'm always looking for a different ringtone because anytime I go anywhere, especially at a Android conference, Android meetup, like if that notification sound comes in or a phone rings, like everyone grabs their pocket at once.
Yeah. So those are our picks for the week. It's time to wind this show down for this week. You can find the show notes for this episode at fragmentedpodcast.com/episodes/5. If you have feedback or suggestions for us, as always, please send either Donn or me a tweet. You can add the hashtag #FragmentedPodcast and we will get back to you right away. We've been getting an amazing reception for this podcast, and we want to thank all our listeners for your support and for being so kind with your feedback and also giving us very useful suggestions. Please always keep them coming. If you want to get a hold of Donn, how should they do that?
You can get a hold of me on Twitter. My handle is Donn Felker. That's DONNFELKER. Remember, that's 2 N's in Donn. Or you can just reach me through my website at DonnFelker.com.
Excellent. And if you want to reach me on Twitter, I'm Kaushik Gopal. That's KAUSHIKGOPAL. And you can get a hold of all the stuff that I do on my personal website. That's KAUSH.co. There's one thing I want to actually mention. So Ion, the library, is by this person called Kaushik Datta.
Yeah.
And people initially, when we released the podcast, were like confused. Oh, is it the same Kaushik or is it a different Kaushik? I must say it's a different Kaushik. We're both different Kaushiks. Our surnames are different. So I thought I'd close with that note, given that we talked about image libraries. Catch you all next week.